ahead, read it. Okay, since we're talking about what is a class, you probably have some idea. We've been working with classes since the very beginning when we were in Greenfoot. All of our classes were derivatives of the actor class. And common examples would be grebe or crab or lobster. And you've done everything that we're about to do before in the Greenfoot and in other contexts, but maybe not as explicitly as we do it today. So I grabbed this from that link, and I'll share this with the assignment. And you can look at it. There's a lot of great information at that link. But a class is a user-defined blueprint or prototype from which objects are created, also perhaps instances. And it represents a set of properties or methods that are common to all objects of one type. So, for example, a customer might have class, might have properties such as name, account balance, date of account creation, address. Those would be properties in which each customer object that you create would share those properties, although they would be stored separately. In addition, a class might have methods such as update address, update balance, and other actions, report balance, that may be useful for users of that class. So, those methods are typically actions. Well, a little bit more. So we found that classes consist of instance variables, and those are the things that you put up at the top. They usually begin with the word private. Private int, customer balance, private string, name. So those are properties that all instances or objects of that class type have in common. Additionally, there's either one or more constructors, which are methods used to create an instance or an object of that class. So we've also had experience with constructors. You did them way back in the fall by creating a crab class constructor, maybe a lobster class constructor. Again, we're about to do it more explicitly. Additionally, there's accessors, which are methods, that report on the state or values of instance variable, such as get customer balance. That would report and return the current state or value of the customer balance variable. So that would be an accessor. A mutator is a method that changes the state or value of an instance variable. So add purchase might be a method within the customer class that adds a purchase by that customer to their balance. So since classes are made of properties and methods, it's useful to go through a review of method headers here. And you can see from the diagram, one, there's a visibility modifier, public, which says that you can use it outside the class. If it's private, and there are private methods, typically it's used within the class only. An example of that might be a fraction class. Outside the class, it might not be useful to, call a reduce method, which would put the fraction in its most common terms. So after calculating or changing a fraction, it might internally call a private method called reduce in the fraction class, which would tidy up the instance variables, which would be the numerator and denominator, to be expressed in their lowest common terms. Additionally, there's a return type marked by int, and there may be no return type as noted by void. And after this method gets done, which perhaps adds a and b, it would return the sum value. So a return type is what is returned after the method gets executed. And finally, in the method header are parameters, sometimes called arguments. And here we have int a and int b. They have, a type, which is int or string or whatever type you want to send into the method, and a name, a or b. It's that simple. You can have any number of them, and those are values that go into the method that are usually useful in having the method execute. So if you don't know what two numbers to add, you can't get very far with an add method, so you have to send the two variables in this case. So be aware of the terminology. I'll be using it going forward a lot. So you've heard me say the art of communication. The secret to programming is managing communication between different parts of the software system. So really, the software system is composed of classes in a modern object-oriented approach to programming. And, it has been, fooled around with by students. The OOP, you can see how they might fool around with it, but stands for object-oriented programming. So the software system is comprised of classes. And you knew this from Greenfoot, right? Because there's the world or space class, there's asteroid, there's rocket, there's explosion. All of these classes interact in a way, each of them with objects or multiple objects in the case of asteroid, that interact with each other to create the software system. And in that software system, parameters and return types are one way of communicating. There are others. They're the subject of the AP class, so stay tuned if you're going on. But parameters and return types from the previous slide are perhaps the thing you need to master and have cold after this class and understand, because he who cannot write and understand a method header is lost in managing the communication of the software system. Additionally, I think that, like I've mentioned already, if you don't master it, you basically wasted your time in this entire class. The big takeaway from having taken this class, if you never program again, is that programming is an interlocking art that is comprised of many complex parts and has a rigorously defined communication system. So that's it of the assignment. We've gone over basically a review of classes. And in this part, I'm going to show you how to create a class using codeboard.io. And you'll follow these steps and create your own as an assignment, which is due about the middle of next week. So the first step is to create a new project, and I'm going to click here in codeboard.io. Pardon me. I'm going to call it Class Maxwell, and obviously I've gone through this again. And what you would do is choose Java and not, as some people have, Java JUnit. And I'm going to have it private project, accessible by the owners and users. And I'll just hit create. So I want to remind you here, before I open it in the IDE, to edit the project settings and go to access control and give me MCQ Max access by adding it here with full control. So with that, I'm going to go back to the project up here, and I will also be adding you as users to my project so you can take a look. Okay, so look for it when you log on to codeboard.io. As I said before, I'm just going to open in IDE, and we get this look. It has a main method which outputs hello world. And if you're new here, in order to compile it, you would click compile, and to run, you would run, and it would output as the method main command has hello world. But in order to create a class, I'm going to go ahead and add a file. And I'm going to follow that example that I used throughout the PowerPoint presentation, which is customer. Typically, classes begin with a capital letter in Java. It's not a rule. It's just by convention. And you need, in this instance, codeboard.io to go ahead and add the extension .java. So I have now a customer.java, which is a blank template. The first thing you would do is create a public class customer statement, which creates the class, and it automatically adds a brace. I really love that because for beginning Java programmers, managing the brace is sometimes an issue. Now to defining the instance variables. I'll start with the word private, meaning they're not accessible outside the class. String name equal quote, quote, quote. And it's a good idea to give them an initial starting value. In this case, name has nothing in between the quotes, so it's empty. And likewise, a customer, well, let's say it's an int, and it would be cust ID equals 0. Okay, so each customer would have an ID. And let's say customer also has a balance, and initially it starts off at 0. So I have private double balance, private int cust ID, private string name. And that's a skinny customer, because your customer or another customer in the real world would probably have like an address field, not just one name, but a first name, last name. It would have an itemized list of purchases. Okay, it would have perhaps documents stored, such as PDFs of statements. And so it would be much more complex, but for the simplicity here today, I'm just going to leave it to 3 properties that all customers share: name, cust ID, and balance. Moving on, I'm going to create a constructor which will allow me to create objects of the customer type, or instances. And it's got to be public, right, dudes? Come on. Because you need to create a customer somewhere else. And no, it doesn't have a return type. A constructor has no return type. And incidentally, the name of the file, customer.java, the name of the class, public class customer, and the name of the constructor have to be exactly spelled the same. So string n, okay, when you create a customer, the name will be given. And int ID, and double val. And you can see these kind of line up with the instance variables, n being name, id equal cost id, and balance relating to balance. So let me show you how it's typically done. Name equal n, and so the parameter value is stored in name. Cost id equal id, and the value in id is stored in cost id, and likewise balance equal val. So that's pretty much it for a constructor. It allows a user of the customer class to set the instance variables or properties at the creation of the object. So let's go a little further and create a get name method, and in case a user of the customer class would want to access the name, we would create a get name method that would just return name, or the value stored in the name instance variable. And note, because it's stored up here in between the opening and closing brace of the class, it's accessible anywhere within the class. That's why they're sometimes called class instance variables. Okay, so I'm just going to go on a little bit and go int get id. Well, maybe I'll just back up. I certainly could do that. You saw that. Double get balance, and it's what we're all trying to do. Okay, and we're going to return balance. And I'm going to stop there. Obviously, I could create a get ID method, and optimally, you would have a get method for every instance variable in your class. But here I'm going to start with a mutator. So I'll just go public void, because typically a mutator doesn't return values. It just simply changes the state of an instance variable. And I will go update balance, and when a purchase is made, the balance is updated, and it will add something called item cost. And inside that, what happens is it would go balance, if I spelled it right, equal balance, if I spelled it right. Some truck is going by, to hear that. Item cost. So when you make a sale, you'll call the update balance and add the item cost in, okay, to the balance. Sorry, that's not an equal sign. It should be a plus sign. So I eased up on the shift key a little bit. The alternative way is balance plus equal item cost. So take a look at that either way. I think you can see that if those two statements are equivalent, what the plus equal sign does. And both of them add the item cost to balance and then store the value back into balance. So that's pretty much so far what we have for customer. Again, it's a skinny down version. So just going to click compile here and see what the error is, and to make sure, let me scroll this back up, take a look. And so it looks like I have an error on line 20. It says right here, aha, I'm missing a closed parentheses. So it's a good idea to compile as you go along. Maybe not line by line, definitely line by line for a beginner. Perhaps not quite line by line, because you have to complete a whole method before you can get to the type of error that I made, but periodically. Okay, so let's switch over to main and use our customer class. Basically going to take out the hello world. Maybe I'll leave it in. Okay, and I'll create customer X equal new customer, and I'll be the first customer. Okay, and my ID will be 1 and my balance will be 1031. Okay, so I've created a new customer, and that's not a problem. And basically what I'll do is X, okay, dot get name. And since that returns a value, which is the string, I'm just going to output it to the screen. X.getName, and output it to the new screen. All right. I like that, so I'm just going to copy it. I like to save typing because you know I'm not the best, not the worst either. And I'll go with the other method that I have, which is getBalance, which is what we're all looking for. I think I made that joke before. And then what I'll do is, since it's not returning a value, it's a void method, I'll go, what did I call it? Update balance. Okay, x.update balance. Wow, I'm really having a hard time typing balance today. And if the balance was $10.31, I'm going to make a purchase of $5.73. And just to see that the work of the update balance method is done, I'm going to output it again right here and run that. So let me compile it again. Okay, return name. Okay, let's see. Let's go back to here and say must be in here. Get name. Must be a problem in the return type. Oh yeah, right here. See where I said it returned a double? When I called it, it's got to return a string because name is a string type. So I love to put the flaws in there because you can see how I figured it out. And now I'll compile it again. And what I'll do is I'll run this. I have to compile both files separately. A little bit of a problem. Now I'll run it. Oh, yeah. All right. So I got hello world. It outputs the name. It outputs the balance, 1031. It adds $5.73 to the balance and then outputs the newly revised balance. Okay, so that's how you create a class. I'm just going to add a little feature and leave you that. You can add java.util.scanner. Most of the standard classes will work. Just to remind you, you can't do anything like frames or things that we were doing here before. Now take the hello world out and I'll create a scanner. Scan, I'll name it scan. New scanner. And it takes the parameter system.in. Okay. And I like things to line up. Freakazoid. Okay. And then right here, I'll go string n equal scan dot next line, and in place of John, I'll put N. Okay, so you can do that with any of the variables here. Next int, next double. These are ways to input those values using a scanner class. And I'll compile it again and then run it. And so it's waiting for input down here, and I'm reading a book on Woodrow Wilson. Cray nerdy, okay, ask me anything about Woodrow. And I'll enter Woodrow, and boom. So this is the input line down here. All right, so I want you to be aware of like how to interact with your program. Oh, this is it. To summarize, create a class with a public class statement following the name of the file. Create a constructor. Create a few accessors and one mutator. Test it in the main program. Make sure it runs. And that's your assignment. The only thing is, you can't use the customer thing. If you got a stamp collection, each stamp could be an object. If you have a comic book collection, a Pokemon collection, it has a name and a type and maybe a level. A student object, go ahead and be creative, okay? Toys in your toy chest collection, colleges that you applied to, these types of things. So keep it skinny, don't go crazy with the instance variables, or if you have a lot of time on your hands, go ahead. But that's the assignment, and here's how you do it. This is Max, by the way, to exit, okay? Make sure you save all the changes if you're not in a compiled state, and then you can go ahead and exit. And you can see it listed here, and when you do it, I can see it here. And by the by, see how I named it class underscore Maxwell, and you named it Here We Are Again? Please name your project class underscore your last name. That makes it easier for me to give you credit. I spend hours at the computer, and so do you. Make things easy for each other. Max out.